Hello, my name is Richard McLaughlin, and I'm a student at the University of North Texas. My video today is going to be over my midterm project for my data analysis class. And this project is going to be over a Pokemon dataset, which actually comes from Kaggle. And we were given this dataset at the beginning of the semester as a part of a list of choices. I personally chose the Pokemon dataset just because I've been playing the games since I was very young, and I'm very familiar with this data already. And this dataset actually includes quite a bit. Let's go ahead and scroll up here. It includes the number of the Pokemon, which is kind of like a unique ID that they made. The name of the Pokemon, their typing, and some of them are dual type, some are single type. So the blanks are actually perfectly okay. Their total of each of their stats, so it's going to be these all summed up, and those stats are HP, attack, defense, special attack, special defense, and speed. It also lists their generation and whether they're legendary or not. And you can see here I actually added another column called date introduced, and this is just going to be the individual date for the release in North America for each generation. So there's going to be 6 different dates, just so they're grouped together nicer. And we're going to be doing some data analysis a little bit later. So let's go ahead and get started. In my initial analysis, I wanted to answer 7 questions. Generally, what's the strongest Pokemon in each of these different areas? And I kind of define strongest as kind of strongest on average. So let's take a look. We're going to answer each of these. Which Pokemon has the highest stat total? And I actually did this using some formulas. The first formula I wanted to go over is which I used for each of these stats. To find the highest value of each of these stats, I used max if, which basically just says, okay, well, I want to find the max value in this column where this column equals this value. So I wanted to find the highest base stat total based off the total column, and it's going to check the legendary column to see if it's true or false for this first case, because they're grouped legendary and non-legendary. So you can see here Arceus was actually the highest base stat total overall, with stats of 120 in each. To find each of these values, I just did a lookup function. We used index match, which allows it to look left and right of that lookup value. And I also added 2 conditions, and to actually use 2 conditions, I made this formula an array formula. I wanted to see, okay, well, is it legendary or not? And, where is it equal to 720 in the total stats? I did this for each of these and imported the rest of the data here. And each of these actually have different numbers, which represent the columns that it's going to be pulling from, based off the location of this lookup value. So it's going to look a little different for each of these. So now that I've actually found all of these answers, let's move on to some basic generational differences. And I had another question, which was, what's the highest stat total on average? Okay, well, we can do that with an average function, and I used average if here. It's going to average the total base stats if the generation equals 1, 2, 3, 4, 5, and 6 respectively. And you can see here I highlighted the answer. The highest number is 451 and 0.9, so 452 thereabouts, and its generation 4 is about the highest on average. And also, something I could do for the generations is make a pivot table of, okay, well, what's the highest base stat total overall? What is it for each of these? Well, it turns out the first 3 generations, they kept it pretty tame at 680. And generation 4, they kind of went a little bit crazy. The highest stat total was 720, and I believe that belonged to that Arceus legendary Pokemon. And let's see. You can see it kind of diminished over time, so they kind of tamed it back down. The second pivot table I kind of wanted to make was, I wanted to see, what does that data I made before look like in a more tabular, more kind of typical look, and also I wanted to graph it. And I wanted to use pivot tables as a technique just to practice more. So you can actually see here I graphed each of the stats except for the base stat total. and you could kind of compare. So you see Shuckle actually has very high defense and special defense. Whenever you compare it to each of its other stats, you can see the differences for each of these there. So let's see. Let's keep going. And so I mentioned earlier we'd be going over some date analysis. That date column allows me to construct these histograms where it's blocked off by generation and date, and you could actually see the differences of these stats from each generation. So it's gonna be the total stats, total value of each of those summed up, with that condition that it belongs to each generation. And you can see here that actually Generation 5 had quite a bit as well for the total summation of it. And I graphed it in a line format as well, so you can see the change over time. And you can see it really didn't change too much for each of these. I mean, they're pretty uniform. I mean, some are a little bit less. Generation 6 is about half of first, but overall, you'll see that there's some Pokemon that are very weak and some that are very strong, and kind of on average that some are still kind of relevant whenever you look at the competitive kind of play of the video game. And lastly, I wanted to look at the descriptive statistics of each of these stats, and you could actually see each of these have their own means. Base stat total is going to be way higher than the rest because it's a combination of all those stats. But on average, the attack actually is the highest value for each Pokemon. I found out with a mean of 75.75, rounded up, of course. And overall, the variance for each of these is quite high, but the lowest is actually HP. So they're pretty consistent with the HP value there. Something I actually didn't mention before that was an issue with the data cleaning was they actually had these duplicate values for Mega Evolutions for Pokemon. They actually introduced that in Generation 5, where you'd have something like Venusaur, I'll use an example, or Charizard or Blastoise. They added all three of these, and it would be represented on this data set here as a duplicate value. Sometimes the typing can change, and overall the stats are inflated because it's a higher form of that evolution that Pokemon go through. So I wanted to make it as consistent as possible across the generations, and I wanted to leave it at the baseline level. Mega Evolution in the games is kind of a special case, so I wanted to kind of mitigate that inflation as much as possible. And with that, that's kind of the whole project that I had here. It's a summary of 3 different assignments that I had across the beginning of the semester. And with that, I'll go ahead and let y'all go. Thank you for watching, and have a nice day.